Hi, let's get back. Okay, there's one topic that I forget to mention last time when we talked about pointers. Is another technology that C++ provides called references. There are many other ways that C++ try to help improve the usage of pointers, but reference is one thing that is really important. Okay, so let's take a look. Okay, so typically when you want, so let's take a look at one example. You want to swap the value of two variables. If you write your own code, it would look like this. Okay, if you have two variables and you want to swap the value, you have one temporary variable that takes the first variable value, and then you do the copy and then come back like that. But if you directly make this into a function, and then you call swap x and y, you won't be able to swap the value of x and y because what happened is that the value of x and y is copied to a and b, right? This is called pass by value. Then whatever you do with a and b has nothing to do with x and y. So in C, the way you would do this is that instead of passing the value itself, you pass the pointer to the value like this. So let's see that pictorially. So you have x and y. So this is 100, something like that. And then you call and here, my swap one. So let's say it's this function. What happened is that you have a pointer a and b. And then when you say and x, a points to x like that, and y, b points to y like that. Now, you can access the actual value of x and y through a, right? So now you can use pointers to change the value of x and y, and these variables are inside the scope of the function, and these are some variables outside the function. So you can change the value, okay? But writing this every time looks kind of silly because, typically when you refer to a inside the function like this, you always have to dereference it, right? Because what you really want from a is not the pointer itself, but you want to access the value of something outside the function. So in C++, the new syntax is the new kind of type of variables is introduced, which is called a reference. So a reference is basically some syntactic sugar to help you write something like this. So basically, when you say int reference, so again, when you read types, you read backward. Okay, so it's a reference to an int. B is a reference to an int. Okay. With this function, you can just use a as an int. Okay, but what actually happened is that when you call my swap to, you just write my swap to x and y like this, and what's happening implicitly is that the address of x is passed into the function somehow, and then you can use a as a reference to x. So anything you do with a happens with x. So internally, it's exactly like this. Okay, but on the syntax level, you don't really see it. Okay, you can say a is a reference to x, and then you can use a as if it is exactly x. So this is called, in other programming language, this is called pass by reference. Pass by reference. Okay. Okay, this is a nice thing that you need if you know how to use it. It's really help you when you write functions. Okay. Now, okay. So now let's go ahead and take a look at C++ templates and STL. Okay. Okay. So the reason I need to introduce you to reference is that my example use it. So okay. Now suppose you have a function that swap a pair of ints, and a pair of doubles. If you look at it, they are exactly the same, right? Pretty much the same. And having duplicate codes is a sign of something that you might be able to improve. So these two functions are exactly the same, except the int here is changed to double. But when you write a function, the only way you can parameterize in typical function is that it's the data, not the type. Okay, so in C++, you can do something better than that. Okay, you can say, hey, this is my type, right? So I'm not gonna write a function, but I'm gonna write a template. So a template would say would be something that we'll look at that. So we would say like template, and we say instead of passing an int here, okay, so we just say it's a type T, and we use T as a template. Okay, so when you define a template like this, you can use it on other many types, and then internally the compiler would do the replacement and build the code for you. Okay, so let's look at the example itself. So you can say template. So that code would become something like this. So you say templates class T. So T is a type, and now you can use type T as a variable. Okay. Now when you instantiate this function, the compiler would see, okay, so here A and B are ints, then it would internally, okay, generate a code for exactly for this. So it's you're gonna have my swap int, and this is the code. Okay, now if you call my swap with a double, so the compiler will take the template and replace T with double, and you have another function generated for you. Okay, so a template, as the name said, is a template. It's not a function, but it can be used by a compiler to generate a function for you depending on the type of the thing that you are using. Okay, so with this you can have a lot of things. Okay, one of the things that is important, it can be implemented with templates, is called generic programming. So it's a kind of like you have a data structure that that you can use with many types. Okay, so let's take a look at that. Okay, so STL functionalities that we will look today. So standard template library. So it's a template library. It's not the library itself. It's a library full of templates of many things. Okay, you can write. There are basically three functionalities of STL, but we will look at that. The first major thing here. So these are data structure. So most of the data structure that you learned from the last course has already been implemented in STL. So when you write your code, you don't have to say write the linked list class yourself. Okay, but you need to know what a linked list is and the performance of these data structures, so that you can pick the right data structure, the right library from the STL. Okay, so containers and iterators. So these are data structures. So containers is like you want to keep something inside the containers, and iterator is a way to go over items inside a container. Okay, so let's see one example with the real code. Okay, here I have a simple code that basically use a list. When you look at a list, you can think of it as a doubly linked list. So a list is a sequence of items, right? It's a linked list, basically like that. But you can go back and forth. It's a double linked list, doubly linked list. So you can keep, but you only have to think about this in mind when you want to look at the performance. But the idea of a list is like you have an items. Okay, you have an item, Okay, so but what kind of item is inside this list score? So this is a variable. You say it's a list of int. Okay, look at this syntax. So this is the part of the template. You have a template of a list and you want a list of int. So you say list int. Okay, so you can keep an int inside these data structures. So how would you put something inside a list? So you use push front and push back. So a list has a front. So this is the front and a back. When you say, in the beginning, when you say score, you have an empty list, okay? Now, let's look at this code a little bit. I read an n, the number of items, I read it. If it's less than 0, I push front. So if the input is like minus 10, 20, 30, minus 40, 60, something like that. If it's less than 0, I push front. So my list initially is empty. And when I say push front, I have this minus 10 here. And then now I read 20, so I push back, so I add 20 at the end. Next, I read 30, so I put it at the end. Now I read 40, I put it at front. Now, after I read 60, like that. So this is my list. So the list will look like this. It's going to be a linked list. So to be precise, you need a pointer like that. Okay. Okay. But it's going to be a doubly linked list. But let's say I write it that way. Okay. Now I have a list. How can I do something with it? So you need to iterate over the elements of a list using an iterator here. Okay. So an iterator need to be the same, an iterator of the same containers. So you define, you declare it like this. So you have a list of int, okay? And this colon, okay, is a C++ thing, okay? It says you have a type inside another type, basically. So you have an iterator I that iterate over all the elements. I will look like a pointer. So basically, I let I be score.begin. So the score.begin is basically a pointer. You can think of it as a pointer to the first element. Okay. So in the beginning, I would point to this. Okay. And then let's try to understand it. Now I want a value. So I dereference it here, star I. So they are exactly like pointers. Now, if I want to go to the next guy, I increase the pointer. So after I++, I would point to this. Okay. So you can iterate over the list. One key thing is that how would you stop? You would stop with the code like this. So if I is not score.n, so what exactly is score.n? You can think of score.n as a pointer to the element. So this is the begin, this is an n. So an n, you think of an n as a pointer to an element after the last. So if I is not at the score.n, you keep increasing, right? Okay. When I is at this, that means you stop. You at the end of the list, right? So you stop. So this code, if you think about it as a pointer through an array, it's exactly like you would something you would do with an array. So let's take a look back quickly on how would you use pointer to go through the array. Okay. So this is from last time. Okay. You can use pointer to go through an array. You have an array, okay, with 50 elements. So you say you point xp to the first element. So this is like begin, and you keep iterating. You dereference to get the value, and this one is moving to the next guy, right? And then you stop when you at the end, right? Okay. So x plus n is not a pointer to the last element again. It's the pointer to an element after the last element. Same thing here, okay? Okay, so this is how you go over elements in a container, okay? you do that by an iterator. Okay. So again, you want a list, right? So right now we only know one type of container, which is a list. You have to specify the type of element inside the list. Okay. Now you can push front and push back. Front is the beginning, back is at the end. Okay. And this is how you iterate over all elements. So you have an iterator that works like a pointer. Okay. And you take it to the beginning and you iterate. You dereference to get the value. Okay. You can move to the next guy. And in the end, you use the end here, right, to say that you need to stop. Okay. So end at begin is a pointer to the first guy. End is, you can think of end as a pointer to the guy after the last. Okay. So when the list is empty, begin equals end. Okay. But you only you have a function that would check the emptiness for you. Okay. Okay. So list is a linear container. So you have typical access to elements. So it's a linear, right? So it's linear. So you have an item and so on, right? And so you have you can access the first guy called front. Okay. So in the beginning of the list is a front, and at the end it's called a back. Okay. So with these two locations, you have a few operations available for you. So you have front and back. This would access the element in the front, the first guy and the last guy. Okay. You can push front and push back. Push front is you want to add something to the front. Push back, you want to add something at the end. You can pop front and pop back. So pop front, remove the first guy. Pop back, remove the last guy. Okay. Every STL elements use the same concept of front and back, but you cannot, in some type of containers only support a few of these operations because they will provide you operations when these operations are kind of like efficient. Okay, so we'll see more example of that soon. Okay, this is the model of iterations. So any containers you would have begin and end. Okay, you can think of begin as the pointer to the first guy, and end is the pointer to the last, the one after the last. So the idiom, typical idiom that you see I equals begin something dot begin. And then when you check that you are at the end, you use I is not something dot end. Okay. So you see this really, really often. I mean, all the time. Okay. And you can move iterators. This will move you to the next guy. You can sometimes move back. Okay. Say I is here. If you say I minus minus, I would come back and go back like this. So in STL, a list is a doubly linked list. So you can go back and forth. Okay. You can move forward and you can move backward. That's really nice. Okay. And you can dereference the iterators to get the value. So that's how the thing works. Okay. And the way we wrote previously is a really explicit way to iterate over elements. You can make the code shorter. So previously C++, if you want to iterate, this is the only way you can do that. Now, modern C++ has a nice feature called type inference. So when you say I equals score.begin, you exactly know what the type of I is, right? So you can use the keyword auto here to tell C++ that, okay, can you figure out the type yourself and do that for me? Okay, so you don't need to write list int iterator here. You can just use auto, and then the code will look much shorter. So these days nobody writes list int iterators anymore. So you just write auto. Okay, so it really helps. And also there's a new syntax for iterating over a collection of data like this. So you can say for int x. Doing this, you can throw away all the iterators. So this is like in Python. Okay, so you iterate x over the list, and then you can use X right away. So this is another way of accessing elements, and you don't need to know pointer as all, okay? But pointer is really handy. Later on, you see when you want to search an element inside an associative containers, iterator is your friend, basically, okay? All right. After you work on STL, you get more familiar with it. Here is another example of if you want to get the kth element. So what the kth element is, it's not the first one, right? So if you want to get the fifth guy, okay? So you can get I to be the begin, right? And then you need to move for 4 times. So you call I plus plus, I plus plus, I plus plus, I plus plus. So now I point to the fifth element, okay? So that's how thing is. This is how you would write it, okay? So I say I equals score the begin, and then if the k is 5, I iterate for k minus 1 times, and I call I plus plus. But you need to really be careful. Don't go past n, right? So you need to check it here. If you want to make sure that if you really want to get to the kth element, if there's no kth element, you want to print error, then you need to do something else. Okay. But you need to really make sure that you won't go past n. If you add n and you increase the iterators, the result is unknown. Okay, can be anything. You can maybe crash, maybe whatever. Okay, so be careful on that. Okay, so this is how you want to get the kth element. One of the tasks that you have to write will ask you to do exactly this. So this is the code that you might want to use. Okay. Okay. When you want to use STL, you basically need to learn the interface. So there's a website that lists the interface for STL lists. Okay. So let's take a look at that for a little bit. Okay. CPP reference. This is one of the website that I really like. There are many more, right? But let's take a look at that. So this is called. So if you look at container libraries, you'll see a list of containers here, right? Okay, if you look at lists, okay, let's take a look at lists. It's a sequence container. You might not be able to read all of that, right? So it's the template parameters. This is the type. These are the functions that you can do. Okay, assign, back, begin, empty, size, push back, push front, pop back, pop front, emplace. This is like replace elements, resize, swap, many things. Okay, empty. You can check if it's empty or not, the size. Okay, and these operators basically tell you the running time. This is really important if you want to use that. Okay, say the time complexity here. Okay, constant or constant or linear, depending on the type of the element. Okay, the list. Okay, and the list also has the function splice. Okay, so you can take elements of one list to another, stuff like that. There are many options, and the running time depending on the kind of like operations that you use it. When you want to use an STL, if you want to just use it, you can just look at the reference like this and understand the API, and then that's it, right? But if you really want to use it efficiently, like think about the running time, you need to understand what's the underlying data structure of the container. Like when you use a list, you need to understand that the underlying data structure is going to be a list. Okay, it's going to be a doubly linked list. So let me write it properly. Okay, each item you have 2 pointers. Okay, go back and forth like that. Okay, like that. At the end you have and like that, and something that go back to. Okay, so with this kind of data structures, you can easily add something at the in the middle, right? So you update this pointer so that this guy point to this one, and the next guy point to this one, and this one point to this one, right? Okay. Also this one point to this one. Okay. So you only need to update the pointers. You can insert something in the middle of the list. Okay. So if you want to use a list, you can think of it as a data that are easy to insert. But if you have a really long list and you want to get to this guy, right here, you need to go through the list. Okay. So when you want to use STL list, you have to have this kind of picture in mind so that you understand, okay, the running time of each of the operation that you use. Okay. Say if you have an iterator at this point and you want to add something after this guy, that's pretty easy. Or after you want to add something before this guy, that's pretty easy. Okay. And if you want to add something after this guy, you can just move the pointer to this and add something before that guy. Okay. So that's the insert operation that you can use on the list. Okay. But if you want to access to the, the millionth element on the list, that's will be hard. You have to go through the list. That's something that you have to really do. That's what lists work, right? Okay. Now, STL also provide you some other kind of container as well. This is called a vector. You think of a vector as an array where you don't have to pre-specify the size. You can add stuff. So it's like an array, but it's dynamic. You can add more elements into it. Okay. So if you think about an array, it's pretty easy to get to some element, right? So if you have X, you want to access X, a million. That's really cheap. You can just access this, right? So you can do that with vector, okay? But what's really difficult with vector is that you cannot, insert elements, right? There are operations that would insert element in the vector for you, but it takes a lot of time. So if you have the same code and you want to use the same API, if the API between list and vector are the same, you can just replace it, list with vector. But unluckily, you cannot push front with vectors. So the code for vector is pretty much the same, except you cannot use this. Okay, you can use insert explicitly. We'll see more on that later on. And the other parts are simples, are really simple. You can, they are the same. Okay, you can iterate over our elements with the same kind of begin-end iterators. Okay, but since it's a vector, right? Vector is random access. It's like an array. You can also access element with index. You cannot do that with list, okay? Because list doesn't have the interface. You cannot do a random access with list, okay? Okay. Now, if you compare the operations that you can do with lists and vectors, they are kind of like somehow a little bit different, okay? And with different running time as well. You have pushback, pop front. So a vector is dynamic in that you can add something at the end and remove something at the end, but you cannot use push front and push back, push front and pop front, because it's really hard to change something in the at the beginning of the vector. Okay, but you have insert and erase. Okay, in list, if you have an iterator at the right point, this takes O1. For a vector, if you want to insert something here, you need to shift the data, right? So insert and erase would take O(n) time. Okay, and there's some other operation that are not available to vectors. Okay, even though you use the same, you can have the same kind of code. Okay, that insert something at the beginning of a sequence of data like that. Okay, one is a list, one is a vector. The code is exactly the same. You only change the type of L. Okay, but again, insert for list, it takes O1. So this code will run really fast. But insert for a vector, this take O(n). So the overall running time of the whole algorithm is going to be O(n). Here is going to be O(n) square. And you can see the running time here. So let me show you the code, the running time. Okay, so I have the first code in S1. So this is list version. So so you can you get it done instantaneously. Okay, now this is the vector version. Okay, so let's run it. It's gonna take some time. I'm not gonna edit the video so that you feel the pain, you feel the time it takes to run, right? It's gonna take like 10 seconds or something. No, 16 seconds. So same code, same behavior, different container type, okay, different running time. So this is something that you have to really be careful. And this is what we're gonna learn in this course as well, like the efficiency of the code that you write. Okay, finally, there are many more types of containers in STL. So we look at some of this, right? This is called sequence containers. You can use adapter to create a stack queue and priority queue. The other really important kind of containers are called associative. Okay, so this you can use as a you can use you can think of it as a key value data structures. So here you have the linear access, right? Index gonna be go from 1 to n or some 0 to n, but here you can have key value kind of thing. Okay, this is like a dictionary in Python. This is like a list in Python. So you see more example of that later on. And you can also have hash. So this is going to be hashing. These associative containers is a key value kind of thing, but the key are sorted. So you have ordering. You can have something coming before something else, and you can use it to sort stuff. But you can have a more efficient data structure, key value data structures, but the key are not sorted. So you have no ordering condition on that. It's going to be really fast, but it's unordered. So you cannot use it to find the first guy, the last guy, the minimum guy, the maximum guy. You cannot use it with this kind of containers. So these are the overview. You see more example of that later on in when we look at them. Okay. So I hope this gives you an overview and some of the ideas on STL. Basically, we look at vector and list. Okay, and the idea of iterators. So again, begin the first guy, end is at points to the guy after the last guy. Okay, so you should try to be familiar with this idiom. Okay, all right. So this is it. Okay, let's go ahead and work on the task now. Thank you.